My dear students, today we will discuss about lineation. What is lineation? How lineation is being produced, and what is its importance? How it is related to major structure? That aspect we will discuss through this lineation. So, what is lineation? Generally, we see that rock bodies present different types of linear features or fabrics or elements on their surfaces or within themselves due to operation of different types of processes such as tectonism, sedimentation, metamorphism, exogenous endogenous forces over them. All these features or all these processes, they act over the rock bodies, as a result of which we find the formation of linear features or the fabrics, elements that may exist on the surface of the rock body or that may penetrate into the rock body. So these linear structures which we trace in the rock body, they are described as lineations. So if we consider the definition will be like this. It can be defined as a parallelism of some directional property in rock, or it can be defined as the parallel arrangement of linear fabrics in rock, or it can be defined as the repeated parallel arrangement of linear elements in rock. So we see in rock bodies some linear features which owe their origin to different types of forces, tectonic forces or deformative forces, or they may be related to the processes of formation of the rocks. That may be sedimentation, that may be metamorphism, that may be the role of exogenous endogenous forces over them, as a result of which some fabric or some linear elements develop within the rock body, defining their occurrence in a systematic or parallel manner, which we describe as lineations. So these are directional property, parallelism of some directional property in rock, that can be called as lineation. Similarly, or we can say it is repeated parallel arrangement of linear elements in rock. Whatever may be the process, if we see these linear fabrics on the rock surfaces, they can be called as lineations. For example, we have the silken sides, we have the fold axis, boudins, quartz rodding and mullions, elongated lineation shown by elongated minerals, or intersection of lineations, intersection lineations which are produced by intersection of bedding planes and cleavages. Because if two planes they join together, they will produce a line. So this line will be the lineation. Intersection line will be the lineation. And these lineations or parallel directional elements found in rock bodies are classified on the basis of the origin. That is, they may be primary lineation, they may be secondary lineation. Primary lineation may be found in sedimentary rocks, as we see in imbricated structure, arrangement of the boulders, pebbles with their long axis parallel to the direction of flow, defining imbricated structure. So this arrangement in the direction of current or indicating the parallel current direction, they form a kind of lineation, that is imbricated structure. It can be fluid cuts, it can be crests of ripples. So these are in sedimentary rocks we find we find these structures, these linear structures. They can be classed as the lineations, but these are not penetrative lineations. Similarly, in case of igneous rocks, we find these lineations. That is because of the arrangement of elongated minerals such as hornblende, mica in the igneous bodies. If they are occurring in a systematic manner, in that case they define lineation. As we see in case of protons, which are rising upwards, they show parallel arrangement of elongated minerals parallel to the walls of the inverted rock, while the core portion of the protons is found to be devoid of the regular arrangement. So this is the core portion of the protons, where the arrangement of elongated minerals are there, but they are not in a systematic manner. So the core portion is devoid of any lineation. But if we look at the walls of the intrusive body, then we say because of friction of this rising magma with the walls, we find parallel arrangement of minerals, and this happens when the magma is having lamellar flow, not turbulent flow. So these elongated elements, they are found to be parallel to the walls of the inverted rock, and here they show lineation. Here there is no lineation. So this is the case with the protons. Similarly, we find when the magma is rising up and is expanding upwards, then linear elongated minerals are found to form arc. Or when the magma is forced to pass through a narrow opening, it produces parallel orientation of minerals towards the opening, defining lineation. So, in case of igneous rocks, by parallel arrangement of elongated axis of the boulders, cobbles, in the direction of flow, they can define a lineation. Similarly, in case of igneous rocks, the elongated minerals, by their parallel arrangement, they show lineation. So these are the primary lineations which are found in sedimentary rocks and igneous rocks. Besides that, we have the secondary lineation, where the lineation develops in a rock after their formation. So they are not primary. It results due to deformation, it results due to stress, it results due to compression, folding, faulting, stretching, tension. So these are the processes by which the original rock may face deformation, and in them the constituent minerals may undergo alteration and lengthening in a parallel fashion to define lineation. So these are found in rock after their formation, because of which these linear features are described as secondary lineations. Besides this, we have another type of another classification of lineation that is based upon their penetrative character. It may be non-penetrative type, it may be penetrative type. When it is a lineation of non-penetrative type, the linear features exist on the surface of the rock bodies, such as lichen sides, striations, mineral fibers on the joints, fault planes, wooden lines. So these are of non-penetrative type because they exist on the surface. But there are cases where the lineations are found to be penetrative in nature. That means the linear elements or linear fabrics is found to be distributed more or less in a uniform manner throughout the rock body, or they penetrate into the rock body with more or less uniform distribution. These penetrative features or penetrative lineation mostly owe their origin to deformation. If lineations are found to be uniform distributed within a rock body defining penetrative lineation, in that case the rock is designated as L-tectonite. Lineation bearing tectonite, L-tectonite. Also, it is found that the foliation planes present lineation in them. Normally it happens, and the rock displaying such lineation is described as LS tectonite. Foliation plane containing lineation, that is LS tectonite. There can be foliation without lineation. It is possible. Foliation may exist independently, devoid of lineation, or it may contain lineation. The oldest lineation found in bedding planes are termed L0 lineation or patterning lineation. And the successive generations of lineations are termed as L1, L2, LT3 like this. They owe the origin to different phases of folding. So how the lineation is being measured, or how it is being expressed? It is expressed, or its attitude is expressed with respect to its bearing and with respect to its plunge, pitch or rect. So bearing means it is the direction along which the lineation is extended. Plunge, it is the angle that the lineation makes with a horizontal line in a vertical plane that passes through the lineation. This is plunge. But rake or pitch, they define the angle that the lineation makes with a horizontal line in the plane that contains the lineation. If this is a plane, this is the horizontal line and this is the lineation, then this angle will be the pitch or rake. The horizontal line on the plane, this is lineation. So the angle between the horizontal line and the lineation measured on the plane which contains the lineation defines the rake or plunge of the pitch of the lineation. And what are the symbols that are being used? Simply straight line with an arrow, it indicates the lineation, and the arrow points along the direction of plunge of the lineation. So here it is 30 degree means it is lineation plunging northeast at 30 degree angle. If arrows are found on both ends, then it is horizontal lineation. If it is of this manner or in this manner, it is a vertical lineation. Similarly, a bed may contain a foliation along with a lineation, or a bed may contain contain a lineation. This is a dipping bed and this is the lineation. And the lineation, if it is not aligned along the direction of dip of the planes, then it will have its plunge amount which will be less than the true dip of the bedding plane that contains the lineation. And if it is oriented along the dip direction, then the plunge amount of the lineation will be same with that of the dip of the bedding. And in that case the rake will be 90 degree. In other cases the rake will be varying from 0 to 90. Then what are the different types of lineation that we will discuss? Let us say silicon sides. Silicon sides which are found on the fault surface. This is a strike slip fault and this is the direction of movement of this block past this block, and these are the scratches, these are the markings that come into picture because of the movement of this block over this block. These are striations, scratches which indicate the direction of movement of the one block past the other. So this is silicon side, this is type of lineation. The similar striations on the surface of the fold showing flexural slip folding. Here this bed, because of compression, one block is sliding over the other. So because of the sliding of one bed over the other, we find the formation of these scratches, these lines. So these are the striations on the fold surfaces. They indicate the direction of movement of one bed past the other. Similarly, striations on the bed of the rock produced by glacial movement. What is glacier? Glacier is a thick body of ice that is capable of movement under the action of gravity because of its load, huge load, which is measured in terms of, which is a huge ice body that is capable of movement because of its huge thickness, which may be measured in terms of kilometers. Because of lubrication at its base, the solid ice bodies are capable of movement downhills under the action of gravity. In that case, the moving ice bodies are called as glaciers. When the glaciers are moving, at the two portions they contain these rock fragments which abrade the surface over which the glacier moves, producing scratches, depressions, grooves on the bedrock. These striations, they indicate the direction of glacial movement, and these striations are also called as the lineations. But these lineations are of non-penetrative type. They are of non-penetrative because they exist on the surface only. Similarly, but in case of the flexural slip folding, the silicon sides or the striations that result, they have a large angle with the fold axis, because this is the direction, this is the fold axis. The sketches are like this is the fold axis. So the angle is large angle with the fold axis. And we have the granulations or the Pucker lineations. What is granulation? Granulations are a type of drag folds. It is a type of drag folds, very small scale folds or drag folds. They are small scale folds which are found to develop in metamorphic terrains during folding of citricity planes of phylloids and micaceae. Very minor folds. These lines, crest lines, trough lines, they are very closely spaced and define lineation. The wavelength of folds is measured in terms of fractions of an inch. Thus, the hinges of these granulated folds appear as linear bodies, very closely spaced and define granulation lineation. So, granulations which are very closely spaced microfolds, their hinges, they constitute lineation. These lineations which are produced by lineations, which are produced by these granulations are penetrative in nature, and there may be two or more sets of granulations on the crests and troughs or in the axial planes. These two or more sets of lineations are found to be associated with granulations. And these lineations are also called as Puccal lineations. These are crests and troughs, trough line, crest line, they form lineations. And with depth, they may also form lineations. So, the minor microfolding with the parallel arrangement of the fold axis or hinge lines constitute Puccal lineation. Similarly, intersection of two planes, intersection lineation, it is also called as stripping lineation, that results due to intersection of two planes. Intersection of two planes. Two planes will join together in a line. So that is intersection lineation. So intersection of two planes produce a line or lineation such as bedding and cleavage intersection. They form a lineation on each other's body. Here, these are the lineations. This is the bedding plane. So the lineation is found in the bedding plane by the cleavage or on the cleavage by the bedding. So they are found on each other. So lineations, this is the process, this is the axial plane. So axial plane cuts the bedding. So these lines, they constitute lineation. So intersection of two planes produce a line, and that line can be called as intersection lineation. So this is the lineation. Similarly, we have the elongation of the different elements found in rock, the pre-existing rock grains, pebbles, oolites, pyrrolites, showing heterogeneity in rock composition, may be deformed intensely to produce elongated features which are lengthened along the direction of least stress, defining linear fabrication rock. So these bodies, they are existing in the rock body, they are defining heterogeneity. These grains are present in the rock body, they are defining heterogeneity, and because of stress or because of tension or because of deformation, they are found to be lengthened along the direction of pulling or along the direction of tension, or If it is a compressional case, they are lengthened parallel to direction of least stress, defining their parallel arrangement to constitute what they call as lineation. These represent dimensional elongation of rock fragments in response to stress or deformation. So here we can say these rock bodies were containing these rock fragments, rock grains, and they have been deformed in response to stress. But there is another type of lineation which we call as mineral lineation. Here, minerals are found to be produced during the time of deformation. They are not existing previously, but they are found to develop in the rock during the time of deformation or metamorphism. So, this is mineral lineation. In mineral lineation, the metamorphism, there is recrystallization of elongated, flaky, platy, acicular, needle-shaped minerals such as sillimanite, kyanite, hornblende, mica, which are produced along with deformation or simultaneous with deformation. And because of the very nature of growth, that is elongated structure, when they are arranged in a systematic pattern under the influence of deformative forces, they produce linear bodies in the rock, either on its surface or within the body, mostly within the body, because this is a case of deformation, severe deformation. So, they define penetrative lineation as they develop during the deformation period by the process of recrystallization, and the recrystallization effective over these effective over the formation of elongated minerals. Besides that, we have some other types of lineation that we see in the rock bodies, such as quartz rodding or mullion structures. Quartz rodding, it is mostly found in the nose portion of the folds, major folds. The long cylindrical rods of quartz are found to be aligned parallel to the hinge line. How they evolve? They evolve out of the silica secreted through country rock, which is found on the folded surface, and this silica is found to be granulated through deformation to produce quartz rods parallel to the axis of the folds. And this arrangement produces quartz rodding. So these hinge portions, we have the silica concentration, and which gets granulated like this, elongated on the hinge lines because of their, this is a manner in which they are found to be elongated on the hinge portions they form. So silica secreted by the country rock over these portions, because these places of the folds are the sites of tension. So melting can be possible to produce silica, as it is the low temperature mineral. Low temperature mineral. Silica is found to be secreted in these portions, and it is found to be granulated to produce the linear fabrics, that is quartz rodding. Similarly, in case of mullions, we have the bending of the sedimentary formations during folding, and we find the formation of columnar bodies columnar bodies of rocks, columnar arrangement of rocks, particularly in the nose portions of the folds. They are described as Boolean structures. So it is similar to quartz rodding, but it is in a bigger scale compared to the quartz rodding. Here, these columns, they measure few inches in diameter and few feet in length, and that develop parallel to fold axis. So, Boolean structures are similar to rodding structures, and they are found to be in columns, and these columns may be represented by sedimentary rocks or metamorphic rocks, and these columns are found at the interface of the competent and incompetent rock layers. Let us say it is sandstone or shell. And at these intersection lines or intersection planes between the competent and incompetent beds, the development of columnar structure mostly results either due to folding, or it may be due to intersection of bedding with the foliation during folding or deformation. So, folding may produce columns, columnar bodies along the nose portions of the folds, columns, either due to folding or due to intersection of the cleavages with that of the bedding, resulting in these columns, formation of columns. So, columnar sedimentary rocks or metamorphic rocks, which are produced at the interface of the competent and incompetent rocks, constitute what we call as Boolean structures, and they may present this type of lobate and cusp structure. Lobate and cusp structure. These are the lobates, these are the cusps. Lobate and cusp structure. Lobate and cusp structure mostly found at the interface between the incompetent and competent rocks, because when they are being stressed or compressed or subject to tension, under this condition, the competent and incompetent rocks, they behave in different way, as a result of which these columnar bodies are being produced at the interface. Columns, columnar bodies. It may be columns of sedimentary rocks, it may be columns of metamorphic rocks, and they present lobate cusp structure. These are columns, and the columnar structure is called as mullions. So they will be parallel to fold axis. Similarly, we have the budins. Budins or the sausage structures. Budins are otherwise called as sausage structures or pull-apart structures, or called as chocolate tablet structures, or they are called as pinch and swirl structures, where the competent and incompetent rock beds occur together end are found to be stretched, pulled, as a result of which the competent rocks show brittle deformation and the incompetent rocks behave in a passive way, flows around the competent beds, competent broken rocks, around the dismembered competent rock, around these cylindrical bodies or lens-shaped bodies or pillow-shaped bodies, which result in the competent rock through the tension or these pull-apart process. The sausages are being produced, and these sausages are found to be surrounded by the incompetent beds which behave plastically and flow around the sausages. Thus we find if this is being pulled, this is incompetent bed, this is competent bed, competent, this is incompetent bed. Because of stretching, because of tension, these cracks develop, the solid competent rock is found to be broken along lines to separate these units, which we call as lens-shaped bodies or cylindrical bodies or sausages or pillow-shaped bodies, and this is the flowage of the incompetent bed around the sausages. So we have these lines which separate these units. These are called as Budin lines. These lines which are called as Budin lines. So Budin lines are perpendicular to the direction of stretching. So these stretched separated units of competent beds are called budins, and the process of formation of such budins is called budinage. The processes of getting these sausages or cylindrical rock bodies out of a competent bed through this stretching process constitute what we say the budins, and the very process is called budinage. Through budinage, budins are being produced, and budins are being separated from each other through budin line. So budin line is perpendicular to the direction of stretching. The lines that separate budins are called budin lines, and stretching takes place perpendicular to the budin lines. Here we find these budins, they are arranged in this fashion. These are the budin lines. So they form a type of lineation. These budin lines, they are also form a type of lineation. These budin lines, they are may be found to be filled up by secondary mineral matter subsequently after their formation. And as this is a process of stretching, it is called pull apart structure. If the stretching is not very effective and the individual units of competent beds are pulled there may be constriction. A solid, if it is being pulled, it may not break, but it will behave like this. So here it is being thinned. This thinning portion of the competent bed that do not yield to breaking is called neck. So we get structure like this. So these are the neck portions, and this resulting structure is called pinch and swell structure. So we have pinch and swell structure with the necking, and the neck is called as the neck lines that separate pinches. No, swells. These are the swells. These are the pinches. So these are the neck portions. So neckline. If it is separated, completely separated, it becomes Boudin line. Otherwise, it is called neckline, and this resulting structure is called pinch and swell structure. So it happens when the competent bed do not yield to complete breaking. The process is called necking. The competent beds are pulled and necked without complete separation. The process is called necking or pinch and swell structure. And if the bodies show a variable shape, so that the width and thickness ratio of the boudins are described as aspect ratio of boudins, width to thickness ratio. But in many occasions, the boudins show elongation, lineation with both lengthening in length and breadth in both direction. In some cases, where the structure is termed as chocolate tablet structure. Here, the almost length breadth of the competent bed is more or less same. It is chocolate tablet structure. So boudins are of diverse shape depending upon how it is being stretched and of what material it is being composed of, and accordingly we have different types of boudins. Such as tapered boudin, plug shaped boudin, barrel shaped boudins, fish mouthed boudin, fish like this fish mouth, bow tie vein boudin, this is bone shaped boudin, rhomb shaped boudins. So how is the shape of the sausage structure? How is this shape of the boudin? Accordingly, the boudin is being named, and these are the boudin lines which separates these are the boudins. This is boudin line, and if it is pinch and swell structure, swelling is the thicker portion, pinching is the thinner portion. So in this manner, this is the case where the necking is not separating these units. So this is pinch and swell structure through necking. So buddings, they owe their origin to stretching, and stretching is found to be effective over competent and incompetent rocks, where competent rocks are stretched, pulled, thinned, or separated into units, or so making, and the individual units that result out of competent bed with passive behavior of incompetent bed around it, so linear arrangement, which we define as budding, and it is a type of lineation. Similarly, we have another type of lineation, that is pressure shadow lineation. In the pressure shadow regions of the minerals like garnet, pyrite, and rock fragments in their, or fossils in their shadow region, we find parallel elongated arrangement of minerals. So strong and elongated pressure shadow zones are developed on the foliation plains around rigid objects like garnet, pyrite, rock fragments, and fossils, and these are called as pressure shadow lineation because they occur in the pressure shadow region in the foliation plains of the rocks and rock bodies. So these are the different types of lineation, and now we can account for how they are being produced. The origin varies from type to type, as we have different types of lineation. The origin varies from one to the other, and we can discuss this origin in the following ways. One is dimensional elongation. This is the case when the pebbles, oolites, grains of quartz containing rock show their long and intermediate axis oriented parallel to the axial planes of the folds, defining lineation. Their plunges are found to be same with that of the dip of the axial planes. Hence, they are related to the folding as their attitudes match. So these are the deformed pebbles which have been flattened parallel to this is the axial plane. Parallel to it, this flattening of the isolated pebbles has been possible because of stress or because of compression. So they are related to major structure of the fold. This is the major fold structure. These pebbles are elongated. They lie in the plane of the foliation. They lie in the plane of the cleavage, axial plane cleavage, and they show their plunge amount, which is same with that of the dip of the foliation planes or axial planes. As the dip match, they can be thought to have been produced by folding. So they are related to folding. So folding is the cause of their formation, and their linear arrangement in this plane define a lineation. So folding results in arrangement of deformed oolites, pebbles, grains of quartz to define lineation. Besides that, we have the natural growth of elongated minerals, or we can say it is a mineral lineation. As you see in case of igneous rocks, there are certain minerals which fall with a habit that is, they are found to be elongated in one or two directions. And this elongation does not come under any kind of deformity forces. They are not related to deformation, but their very nature is that they will form needles. For example, hornblende. Hornblende occurs as needles, needle-like bodies. Needle-like bodies. So once they are formed in this manner, if they are arranged in a rock like this, they define a type of lineation. Similarly, mica. Mica is flaky. So mica can occur in flakes. They may help in production of foliation. So their linear arrangement can produce linear fabric in rock bodies. So it is because of their very birth and very growth, very habit of growth, they can occur in a systematic way in rock at the time of formation of the rock and can contribute towards this lineation structure in rock. So hornblende needles, amphiboles, mica flakes, their regular arrangement in rock can define lineation or foliation, but they are not being produced by any kind of deformation. It is by virtue of their natural growth, by their natural habit to grow. So these are called mineral lineation. Similarly, we have the intersection lineation, normally bedding planes, which are the primary in origin, intersect with the axial planes cleavage, which are secondary in origin, and they are related to folding or compressive stresses. So compressive stresses, where two planes, bedding plane and the schistocytic plane or axial plane cleavage, they join together, they produce a line which is called lineation, and they are parallel to fold axis. Fold axis. They are parallel to this is lineation. So folding accounts for the origin of intersection lineation. Similarly, we have the penetrative mineral lineation. It is found in case of rocks which have been severely deformed, intensely deformed. Here the elongated minerals are crystallized through deformation by the processes involved in deformation. The minerals are hornblende, sillimanite, mica, quartz, feldspars, kyanites. So these minerals, they are crystallized out, and their systematic arrangement either in schist or gneiss can contribute towards the parallel linear fabric in rock, defining lineation. The parallel regular arrangement of above minerals define lineation, and several processes are involved in this process or for their preferred orientation. What are the processes? The processes are the particle rotation and bending into parallelism through ductile deformation. There will be preferred solution and chemical reaction in high pressure zones and precipitation in the least stress zones. Recrystallization and chemical reaction to produce new grains from the old crystals. So this is a process of complete recrystallization and alignment of the minerals along the direction of least stress defining lineation. And this is a type of penetrative lineation. Thus, intense deformation results in penetrative lineation. And lineation may originate because of brittle deformation and flexural folding. These are associated with the fault planes and the folds. On the fault planes, we have the silicon sides indicating the direction of movement of one block over the other. And in case of flexural slip folding, similarly, how one block has moved, one bed has moved over the other during folding process. And during this process, we find the formation of lines or scratches on the folded surface. So these scratches on the folded surface, they define lineation. So these are non-penetrative type flexural slip folding or in faulting. So faulting results in development of lineation, folding results in the development of lineation, that is non-penetrative lineation. Besides that, we have stretching or tension lineation, as we find in case of buildings, as we find in case of the pinch and shell structure, as we find in case of rodding, quartz rodding. So these are the results of stretching or tension, effective or brittle rocks or limbs or major folds, or where the competent and incompetent beds occur together and they yield to this stretching or tension forces, producing pinch and shell structure or sausage structure, producing buddings, or they may produce granulation in the silica secreted in the nose portions of the folds to be stretched into rods, quartz rods, so the process of quartz rodding. So this is a process of tensional this is a process in which tension plays its role to develop these linear features, buddings or quartz roddings. Similarly, we have the incongruous orientation of lineation, where the lineations develop simultaneously with the deformation. They are said to be congruous and they are related to the major structures in a systematic way, such as fold axis to folding. If lineation is said to be there, the lineation is said to be congruous because it has developed simultaneously with the folding event. If the lineations are not found to be the systematically related to the major fold, that means they have been originated either after deformation or before deformation. They may be younger or older to deformation or the major structure, and their direction of lengthening or direction of elongation that cannot match with the major structure, major folding event or thrusting event. And there the lineations cannot be thought of to show parallelism, and they are incongruous in nature, they are not congruous. So lineations that develop along with the deformation, which is a common feature, can be described as congruous, and congruous lineations are related to major structures. Even during a single phase of deformation, the rocks may be so badly squeezed that the masses of rock deform practically quite independently of the major structure. Here, the lineation that comes to being is found to be totally unsystematic, and it cannot be seen in terms of parallel arrangement. Linear bodies will develop no doubt, but their arrangement will be very intricate. They cannot be parallel to one another. And in some cases, we find successive lineation that results due to successive phases of folding or deformation. Rock masses may be affected by successive phases of folding and deformation, and each phase of folding produces its own foliation and its own lineation. And these foliation and lineation are found to be quite interrelated to each other as they are of congruous in nature. Hence, it can be concluded that lineations are mostly the product of deformation and they are related to the major structures in some way or the other. Folding, faulting, thrusting, stretching, are some of the processes by which rocks yield to these processes and develop in them linear fabrics or foliated fabrics. And the linear fabrics or linear elements that develop in the rock show parallelism defining lineation, and these lineations may be systematically related to the major structure. Say, it may be related to the major fold, it may be related to thrusting, it may be related to normal faulting. Thus, lineations are related to major structures, and the process of origin of the major structure is controlling the very origin of the lineations that are found to be associated with it. So these are the different types of lineations that we discussed and how they are being produced, and now we will show how a lineation is related to a major structure, let us say overthrusting, how it is related to overthrusting. If we imagine that overthrusting is taking place in along northwest direction, along air direction, so how will be the drag force, how will be the boudins, how will be the silicon sides, how will be the orientation of deformed pillows, and how will be the orientation of these tension cracks and the fracture cleavages. They are either found to be parallel to the direction in which the overthrusting took place or to B direction as shown in the, as depicted in the pictures. So this is the B direction to which these granulation lineations are oriented, these boudins they are oriented, these fracture cleavages they are oriented, and they owe the origin to overthrusting, where the hanging wall goes up with respect to footer, and it can be possible under compressive stresses only. And under that condition we find the silicon sides, they will be parallel to the direction of movement, direction of overthrusting, it is towards A. So these silicon sides they are found to be oriented parallel to air direction. These pillows they are oriented parallel to air direction, but these tension cracks they are oriented parallel to this B direction. So overthrusting results in formation of all these features, but they are systematically related to the axis along which there has been displacement, or to a direction which is perpendicular, nearly perpendicular to the direction of thrusting. To that, some of the features are found to be parallel. So lineations defining arrangement of dark fold axis, arrangement of boudins, arrangement of fracture cleavages, they are parallel to B directions, whereas the lineations defined by flecken sides and pillow defined pillows are found to be aligned along the direction of displacement or direction of thrusting. Thus, this is a simple case where we see overthrusting is controlling the orientation of different linear features that develop in rock due to overthrusting. Thus, it can be summarized that the lineations are the features that we see on the rock bodies are definitely related in some way or other to the deformative forces that caused the origin of major structure in which lineation is a part. Thank you.